Okay, folks, so here we were talking about percent composition of compounds. And you are used to looking at the chemical formula of a compound and figuring out the percent composition of each individual element. Well, I'm here to tell you that you can also figure out the percent composition of elements within a compound, thinking about how these compounds are formed during reactions. So in reactions, we have substances that combine and form new substances. Okay, so in this particular case, let's assume chemist Dr. Sargent reacts 1.26 grams of iron. So let's say I react 1.26 grams of iron, right, with an elemental symbol of Fe. Okay, we react that with 0.54 grams of oxygen. Okay, and I want to know what the percent composition of each element in the new compound is. Okay, so again, I want to know what the percent composition for each element in the compound that gets formed will be. Okay, so here I'm taking a specific mass amount of iron and reacting it with a specific mass amount of oxygen. All right, in this particular case, our very first step is going to be to take the masses of each element that are being combined and add them together. Okay, we want the total mass based on the masses that are being reacted. So in this case, I'm going to take 1.26 grams of iron and simply add it to my 0.54 grams of oxygen. And that, my friends, is going to give me 1.80 grams of whatever the compound will be. Now, of course, I am assuming that these are reacting in completion, so there's nothing left over. So because mass is conserved during a reaction, mass is saved, my compound mass should simply be the combination of the masses making up the compound in the reaction. And then the rest of the processes are the same. Step 2 would then be to take the individual element mass and divide it by our total mass. And then, of course, whatever you get here, you are simply going to multiply by 100. So, for this particular problem set, if I was talking about iron, I'm going to take the 1.26 grams of iron that I'm using in my reaction and divide it by the total mass of the compound here, and then very simply multiply by 100. And I'm going to do this exact same thing for oxygen. I am going to take the amount of oxygen that I'm going to react and divide that by the total mass of the compound that should be left over after my reaction, and then simply multiply by 100. When I complete these calculations, I find that iron is going to make up 70% of the compound that will be formed, and oxygen is going to make up 30% of the compound formed. So this is yet again another way for us to calculate the percent composition of a compound that is formed. Okay, in this particular problem, I have a student who, during a chemical process, took a sample size of 12.2 grams of table salt and separated out 5.2 grams of chlorine. I want to know what the percent composition of each element in table salt was based on this sample size. Okay, so Because I know table salt is sodium and chlorine, I simply start with the fact that 12.2 grams, which would be both sodium and chlorine, and subtract away the amount of chlorine that was separated, 5.2 grams of chlorine, and that would tell me that a total of 7.0 grams of sodium should have been remaining. Okay, so now that I know the mass amounts of the two elements that make up my table salt, I'm simply going to figure out their percent composition by taking, for my sodium, the 7 grams and dividing it by the full mass of the sample size and multiplying that by 100. Likewise, for my chlorine, I'm going to take the mass amount that got separated out, the 5.2 grams, and divide that by the total mass of 12.2 and multiply this answer by 100. So, when you go through and you take your 7.0 grams and divide it by the 12.2 and then multiply by 100, I find that for this particular compound, 57.4% was sodium. And when I take the 5.2 grams of chlorine and divide it by my 12.2 gram sample size, I find that chlorine will make up 42.6%. If I want to double check my math, these two should always total to 100, or for as many elements there are in the compound. Yet one more way that we can use percent composition